BSides Legacy.
So, welcome everybody to our second B-sides, and this time, despite having told that I'll be doing the moderation part, I also, at some moment, participated in call for papers, and despite me having the most bizarre speaker's bio, do check it from the website later, I got selected. So the talk is about something I'm doing at work, and that I have been doing during also past 5 years when I was working at Zone. So a lot of these things are kind of contribution of my current and previous work, thanks to whom I understand these things and I have learned these things. Logs don't lie, even if part of them is lost. We are in the theater. Basically, Vaba Lava is a theater place. So, of course, we need to start with a plot twist. Logs are namely extremely good at lying to you, and especially not showing up when you need them. It has happened to me a lot of times in my life. But I have also, during that, learned how to kind of like massage the logs into being. And turns out that while I actually like dealing with reading the logs and finding the bad guys and everything, then actually most important part of my work, for example, when we were on Log Shield's cyber exercise, was actually making sure that all logs are in proper formats and they reach Elastic. Some scene setting. What I'm going to talk is because I've been dealing with the side of security, which could be web application security. So I'll be looking at the logs, not from the side of malware happening on your Windows computers, but exactly things that are happening in relation to web servers. And somehow, starting from the 24th of February, there has been more DDoS attacks than I've ever seen before. So I'm using that as a case for that. Then we are going into the logs themselves. But to kind of like specify the territory, there is this very famous Google interview question about what happens if you are typing the URL into the browser. So I went out and tried to find is there some kind of explanation, and turns out some Alex Gonzalez, or whatever, has done 300 commits and come up with a very detailed thing, in as much detail as possible. When you go in and you're actually going to see that the part I'm going to talk is just this one line in this thing. And even more. I'm going to talk about the part that request is received by web server. Then probably it is passed on to some application. I really don't care how the application works. For me, currently, it is just something that takes time. I don't go deep into that. And then the responses get sent back. Again, these parts, as I said, I don't care. I'm just talking about basically this part and perhaps a bit about how it is going to get sent back. But what people are doing with the response, who cares? It's DDoS. They're probably not even reading what they are getting there. So anyway. What kind of denial of services I'm going to keep in mind while describing the things I have been looking for in the logs. 3 different examples. The first one is something called a concerned customer who informs a website that they are giving error 500s or something like that. This picture is actually when I checked the logs later and actually painted the number of requests. And turns out that the user arrived at 4:33, started doing different kinds of loads, looking for things, and by 4:46, which is like 12 minutes later, the user had, or the concerned visitor had found endpoint that very effectively took the site down, and actually with very few requests. So there wasn't a question. I think the original one, I've apparently cut away part of the numbers, but I think it was thousands of requests, and then, as you see, it's basically tens of requests it's taking down. Again, interesting to understand how it's happening, because if some random dude can find out how to take your site with 10 requests, then probably this is an important issue. The next case is actually, this picture, by the way, the first picture was like something like tens of minutes, so this is basically the scale down there, 5, 10, so these are seconds. So this is 1 minute of a massive DDoS attack, level 7, so because these sites are behind Cloudflare, so we don't care about lower levels, just what could come through. Interesting to see is actually the red line there is indication of error 500s. And when you see the brown line is the Cloudflare's defense kicking in, so we can say that by the number, perhaps a bit after 10th second of the attack, it starts kind of like doing something, and it actually gears up at the 30-second mark. So until that, we are kind of naked, we are not being protected, and we need to deal with these things ourselves. So the question is, for me, why did it start giving these error 500s? And what do I need to make my ingresses and apps more resilient to these kinds of events? Third one is some person or persons trying out how the Cloudflare works, or how the site works behind the Cloudflare. So the first hit was something like, I think, 4 million requests in 1 minute. The second one was, I think, 3 or 4 minutes, and third one was also, again, 1 minute and something like 4 million requests. In this graph, okay, and the time was like 1 hour in the night, and 30 million requests total. So let's think now about this thing, what is happening behind these attacks and actually on the side of our server. And let's look a bit more detail into what's actually happening. And for me, always the question is that, okay, I know what happened, site went down, but what actually caused that? What was the bottleneck where I need to deal with things? So we can imagine that the same HTTP request, after somebody typed it in the browser or launched in a DDoS tool, it reaches Cloudflare. From Cloudflare, it comes to some kind of our, whatever, Kubernetes ingress or whatever is kind of like there. Sometimes it's just going to maybe some kind of load balancer. There is probably Varnish doing caching. There's probably Nginx serving pages. Then there is something doing the PHP or whatever language processes distribution. And then there is a process which, again, is going to talk to a lot of different things. So what is exactly the thing that goes wrong? Unfortunately, there are things that are repeating, and there is always a lot of specific questions that can be with each of these. We can see, did the Cloudflare trigger? Did the ingress connections run out? Was the page actually cached somewhere? Because I especially picked the picture with blue and yellow lines, because one of them was like, and the page is served by Cloudflare, and another one was page is served by Origin, and it was a static page. So why the heck went half of the pages to our Origin? Why we are not caching it where we could that? There are questions with web server, all of these possible processes in FPM, and actually CPU cycles, which is a thing which working in a hosting company, I was testing a lot, and I found that one of the very easy explanations usually works very well. So if serving one request takes like half a second, 500 milliseconds, and this is not database time, but mostly something happening in the whatever, PHP, Java, JavaScript, wherever, then if we have 10 cores, then 10 cores can serve in 1 second 20 requests. If we have one request response taking 2.5 seconds, then well, we can probably respond with respond to 4 requests per second. When we are now thinking about the kind of the first DDoS attack, then I accidentally did a similar thing a couple of days ago, when there was a question from one of teams that why some server is giving error 500s. And I took the logs, and going over, I found that there was a SEO tool doing site scan. SEO tools are very bad for your sites because they are often visiting pages that are not cached because people don't go to all of the million pages you have. But it shows very nicely what are the slow requests. And I found that for some reason, some specific, and these are actually category pages, were taking very long. I picked the specific category pages and started running just curl to see how long it takes. Curl time is just my alias that runs curl and outputs not what it received, but just how long it took to do, which is kind of nicer to do than in a browser. And well, I have also another command which is time loop. So it's doing the same thing over and over and again. So currently I think I opened 5 browser tabs, started running these 30-second codes, 30-second requests with changing cache buster at the end, just changing number to make sure it's not cached. And I think in 10 minutes the developer was in Slack asking that why are you interested in this product? Because all of the New Relic alerts had went off that there is a lot of very slow requests reaching the site. So basically, and I think, here is the picture. So the blue area is 1 minute, so I think it's 10 requests per minute. And I was able to basically crash the site with 10 requests per minute. I could probably variate more the categories, what I'm looking and everything, because there is sitemap where I can get these. But here it's very simple. Basically, boom, and the site is gone. Now the good part of this log is actually that it had, at the end of the line, also similar seconds. The seconds don't match exactly because I'm taking them from kind of a slightly different part of the test. But I can very easily understand what's going on there. Unfortunately, when we are looking at your average web access log, then it turns out that it doesn't have that kind of data. And it is very difficult to understand what is the application actually doing while it's under stress. Because for me, the indicator that it's just running long time is indicator which helps me find. But there are other mistakes in this particular line. First, the IP address. Because often the web requests comes through different parts. For example, it starts with a Cloudflare. Cloudflare comes to your load balancer, whatever, ingress. There it goes to Varnish, and so on. And the web server usually, or actually the one which is currently processing, gets the request from the previous guy. So by default, everything tends to be the previous guy's IP. Next question is the time. When you're looking at the time in Nginx logs, then what time you're actually seeing? Any idea? It's the time of end of request. So if you are trying to kind of like find a race condition, which request came first and crashed the site, then you are going to find my 30-second requests way after things happened. Well, there is no milliseconds because, and when we are talking about 4 million requests per minute, then you need to have a couple of decimals to think about that. The duration, and also what served that. Was it actually this application? Maybe it was a statical file and I should kind of like completely get rid of that from the logs to make it more easily readable. Fortunately, the version I was using there was Kubernetes Ingress Nginx, which has a default logging format. I think unlike Nginx Ingress, there is completely different configurations, Nginx Ingress and Ingress Nginx. And I especially shout out to my colleagues who have named their Ingress Nginx as Nginx Ingress. So whenever I'm going to look for a configuration settings, I'm kind of like just going crazy. Anyway, it has cool things. It actually tells, it has correct IP address, time, okay. It does have the time it took to serve, time actually how long it took to talk to Upstream. There is also the specific IP of this Upstream service, and then I know, okay, this one went to these guys, and now I can start looking what they did there. So providing more information in the log files is something that when you are setting up the system, it's better done the first thing, because afterwards everybody forgets that there is a need to kind of like configure the server, because server usually gets to kind of like configure the first thing and nobody looks at that later. This is now a bit wider view, and while it is actually copied from Excel, because I needed to get this data somehow on one page, this is actually from Google Cloud's, what's the stack driver or whatever is there, the logging system. So the same requests I showed have actually 3 different times. So we have the end of request processing time, which thankfully is very informative. I know when nothing stopped happening, where everything stopped happening. There is a time of receiving the log line, and usually the first one is the time the log was received in some kind of logging system. It is very common when you are loading the logs into, pushing them into Elastic or wherever you are running them, that they tend to have, the time you are seeing is the time it was received. And this is kind of like, it usually takes a bit of configuration or making sure the field is named timestamp or actually looks like a timestamp or something like that. But yeah, probably this time doesn't look automatically like that. So we actually do need to know when did we get the request, in which order they actually came in, and then we can start off trying to see that what is the relation, why did things go the way they went? Because I think one of the very common problems when things start to snowball is that there is some kind of database lock, something in the backend is happening, or maybe the server is making some external request to somewhere, and this kind of like the request stall, and server eventually is dead. This is actually how I like my logs. This is my own log configuration, my default configuration for Nginx. if anybody ever wants that, you are welcome to, I don't know, find me on whatever media or here. Ask me later. I can show you that. I have also on next slide. But I do have the request start time. I have the request end time. I have the request duration. Okay, I could calculate having one time and duration. I can calculate other time. But it's kind of like very convenient to have them so I can sort the request by start or end. And if I see, like, for example, that all of the requests started ending at the same moment, it means this moment is when the lock was released wherever, and I can confirm this was a lock-related problem. Remote address, user if it's logged on, remote port. The remote port is also cool because when you're looking at all of the traffic coming from mobile operators who are doing NAT at IP4, then probably the only way, if they are logging, how you can go to the police and find out the person who is behind that is if you are knowing the remote port, if they are logging it. Request length, how much data was sent during the request. This is a post request I'm showing here, so I know, okay, it's 5 kilobytes. Looking at the same application, at some time I started seeing very long post requests. So I knew there was a problem at the side which was sending data to this particular API. For some reason, the requests were growing, so I needed to fix the front end. Two interesting things, request URI and URI. What's the difference? One is the one which web server got, and another one is actually what script was executed as a result of that, which again kind of often helps me understand what's going on. Arguments there are not, there is host. And I have a couple of host names. The host is actually the host header of the request. Yeah, you are saying it can be forged. Cool. If I see it forged, then this is interesting information for me. So I need to probably look at these requests more. And also actual host name, which is the server from the web server configuration, so I know exactly which part of web server was serving that. Status points, return, content type. Again, very cool to know what the server actually thinks it sent back. It's JSON. Okay, but if, let's say, if we are, I don't know, getting maybe accessing CSS and it outputs, I don't know, HTML, it's a bit suspicious. FPM1, did it use actually the application? So I can very easily sort out from the logs the lines that are running the code. Because if it was not running the code, probably it's not causing me DDoS problems. It's not something that hackers are trying to, I don't know, abuse. So very little information. Upstream response time, which might be different from the request time because it takes time. And also the difference between these two times shows me that okay, if they are close, it's not a problem, but if they are very separate, there is a question, why does the response from the upstream take so much, but the full request is longer? Again, when you're looking at the servers doing bad stuff during attacks, there are moments when the two things get kind of like much separated. And the also very cool and fakeable header, X forwarded 4. We are coming back to that, but I recall Ethan once mentioned that when you were looking at Spectix's kind of access logs, it was interesting to see that people snooping around were using some kind of VPNs or proxies, and these proxies very nicely added the X forwarded 4 header, so it was also actually visible what it was. So currently, it's actually interesting. The main address is Zscaler, and then the forwarded 4 address is some from South Africa. Zscaler is basically what it is, zero trust provider. They are describing themselves as a leading zero trust, whatever stack in the world. So basically, yes, somebody is using their network and accessing this site. The configuration. Actually, I'd like to see same thing also in the health charts of Ingress Nginx, and the other one as well is calculating some specific values. I'm setting, because it can be only set on the server level, so it's below, I'm setting the start time. You can actually in Nginx record the start time of request if you are configuring a variable yourself. So this will be the start, and the final request time will be just the end of the request, which is usually logged. Why I'm doing these safe numeric values? Well, this is because I like to put the numbers in JSON as numbers, not strings. Makes it easier for later to interpret. Turns out that it is very important whenever you're configuring your log ingest to make sure everything gets proper data type. For example, we found out during log shields, we wanted to make some filters for IP addresses and use zero notation, not adding IP addresses one by one to see what the red team is doing, of course, or maybe real users. And turns out that if it's string, it doesn't work. It needs to be IP address, so you need to make sure all of the formats are always correct, and it's always, again, better to do these things at the very beginning of your logging process. And then get the real IP. Again, my examples are from my life, where I'm behind Cloudflare. So here is two things. First, I'm using Cloudflare specific header. I can be sure that Cloudflare is not letting it be faked. I've tried, at least I couldn't. Maybe some people can. And only if it's coming from their IP addresses. To be sure that it's not spoofed, and I can always trust that. Interestingly, the IP address set of Cloudflare has changed over past years. I think not very often, but there was a change. There was a part of, I think it was this 104.16 or something like that, where they took one part, which is currently used for Apple has for iCloud Pro users some private browsing solution, which is using Cloudflare, Akamai, and Fastly networks to route the traffic. So it's going there. Also, Cloudflare's own Zero Trust, I think, is using the IPs from that range. So it turns out that when you don't know that, you can actually start thinking that, okay, how are the users coming from Cloudflare, or what's happening? And Cloudflare doesn't provide their users of IP, of course, in X404. Funny part with that is whenever you are setting up web applications, there is this chain of all of these participating points that all need to get the first and correct IP address. So my configuration on that part is that when I get it in the ingress, I make sure it's Cloudflare IP. I make sure nobody else but Cloudflare can access this our ingress, and then I overwrite the X-forwarded 4 with this information that I know to be correct. So there is no question, because X-forwarded 4 can contain multiple IP addresses, and it's always the question, did the programmer actually read the manual correctly and decide if they need to take the first or last one, or maybe the middle one, or I don't know, put them all together. So all of this pass, and it's just, I'm just kind of like starting from the insidemost thing, let's say PHP, setting my X-forwarded 4 header, and seeing if it comes, the stupid number comes through. If it comes, it's bad. If it's some internal IP, it's bad, so I kind of like go the setup to the end. Because there is always some smartass somewhere who has decided to implement whatever they found on Stack Exchange. So when you're looking for getting for an instruction to getting client IP in PHP, you are probably arriving on this page, which has actually, for some reason, this one isn't the topmost answer. There is a lot more wrong answers before you come to that, for unknown reasons. Maybe it's so down because it's a security problem, so say they are having those comments which are, well, so those answers which don't explicitly say they are security problems up there. Yeah, in comment, editor's note and comment, this is bad thing. But yeah, somebody always does that. So you have kind of like passed everything through. They are going to find from somewhere, from some rare header, the wrong information and using it because it's so cool. Client IP was also. Let's now look at the things once more from the DOS part. So what was actually behind this picture that I was able to understand thanks to just looking at the count of requests? This was a nice MP4 video sent to customer, our customer, by a concerned citizen who demonstrated that they found a login page and opening Process Inspector, there is a request, and then they are going with that to copying the things and going with these into something called Open Bullet, which probably is a good tool for you to test your own servers in the same manner. And I said, okay, I understand, okay, you're doing a login for n times, the hashing of the password probably takes time, it's okay, it's easy to crash a server. And then I watched, why does it say error 400? Not something like bad password or whatever, not matching. And then I found that, haha, the script kiddie didn't notice that the original question had content type of application JSON. This one had form encoded, so there's some kind of middleware API decided that, okay, I'm not going to do anything. And despite being the API doing some decision on the most elementary part of just making sure that, okay, this doesn't look like a JSON request, let's not serve that, he was able to take that down. There was wrong content type. I think it was related to the question that just somehow the Node.js backend died. Again, because I've seen a lot of cases where people don't understand that the Node.js application, when you launch it, it's basically a single thread, or let's say single worker. You need to kind of like make sure there is more of them doing the work. So probably that's what died there. Alternative fun scenario, which I've seen for multiple times, is malform requests so forwarded to whatever is behind the API, Elastic, which gets an error, which is not caught, promises are not fulfilled, and system dies. Very cool. That's now the second DDoS mitigation. It started with a request set like that. It quickly went up into trying to provide changing URL and bypassing caching. Interestingly, this is wrong query parameter. They didn't check what's the correct query in this system. So it didn't actually try to run unique queries for everything. It still crashed because there was just so much of them. And the interesting part is that the kind of starting of the Cloudflare has very good level 7 DDoS rules. There is basically signature number 15, which I think is that it has strange-looking user agents. But the most probable one is that the origin is going to give errors. So basically, Cloudflare's level 7 DDoS protection very much depends on your server dying. So basically, if you feel it's too much, start giving error 500s, Cloudflare takes over. Just make sure you kind of like stop giving 500s later. So this one was, again, 4 million requests. I think the 1 minute and 4 million requests kind of like seems to be a repeating pattern here. Something like 4,000 IP addresses doing somewhat more than 1,000 requests, but it's not that much. And unfortunately, most of the rate limiting is very stupid. You can rate limit requests per IP. And if they are doing 1,000 requests to basically the same URL, then it's Just for them, it's just 1,000 requests, which is completely different than actual user traffic, which is usually requests in different files, different API endpoints, and so on. And we also learned that the recovery took way longer. Why did it take longer? Because all of these paths, somewhere it was stuck. There was probably some problems with ingress. There was probably some PHP, the actual application back there, which was struggling. It probably had overloaded the SQL database and whatever. So until all of these queues kind of like empty themselves, the site was down. So 1 minute DDoS, even if the protections kick in at second 30, then recovery from that might be actually maybe 5 minutes, maybe 8 minutes, or something like that, depending how well you have looked what actually is happening back there. So that's the point where I went away from looking at the access logs, and I started actually correlating the times to the logs I have about the different server components' performance. Again, that's why it's very important to have correct times, because otherwise I can't correlate these things. If it's kind of like log has lines which are telling that when everything ended, then how can I find the start of the attack? Which brings me to the last example, which is when DDoS detection has left the house. It happened some time ago. The official answer came later to me was that, oops, yeah, we had some kind of problem with false positives or false negatives in rule number, whatever, 15. I don't know how they didn't notice that the server is giving error of 500 also, but anyway, somehow it happened. And for me, it also happened to be a very inconvenient case, because it wasn't our enterprise Cloudflare, it was client's own Cloudflare Pro, which is a very good service, but I can't get the Cloudflare logs. And I'm actually kind of like, I totally like that even if they let the DDoS is through and whatever mistakes that happen, we are still friends, because I can get super quality JSON formatted logs that have start time with milliseconds, end time with milliseconds, what happened, everything. And I can just sit and take all of the 4 million requests and then start painfully going through them and seeing what actually happened. This time I didn't have. So what I had to do was I had to resolve to whatever the actually web servers had provided to me. And turned out that the yellow is the normal traffic and the peak is then the what they were able to take until they went down. So I think there is currently capacity, I don't know, by eye, maybe 15, 20 times. So I think kind of like for normal use, everything is okay. But of the 4 million requests I think I saw in my side logs, I think it was 58,000 or something like that. It was 1.6% of the logs that I actually was able to get. And started to work and draw the duration of the attack and whatever happened. And then I noticed that actually most of my logs were with error 499, which means that the client has left the house. Basically, the DDoSers very nicely made the requests and didn't bother to wait until the end. For my side, all of this long chain of all of the requests was booted up, the application started working, and the guy said, okay, I'm going to do something next. So I had full of the request log of these things. I also found that, okay, there was fake IP addresses, which turned out multicast addresses and something like that. I found out that the default ingress configuration is trying to reach the backend 3 times. So basically, our own ingress was increasing the load on application which was already down. And instead of just saying, error by 500, no, guys, go home. No, nothing to see here. It just kept, can I get something? Can I get something? So, and I also found that the log is very cool because the log at some point has one IP address and at some point has at the same time 3 IP addresses separated by commas. It's very difficult to parse that. I also found, then I went back, and because I didn't have any real IP addresses, I started looking what fun I can do with fake IP addresses. And I found that this particular botnet is just generating addresses with all 4 parts of IP4 address starting from 100 to 255. So, again, interesting piece of information to use. That is also interesting that some of the IP ranges are not spoofed. I'm not sure why. And then I went actually to look how things are happening in the container land, and I found that, yes, in 50 seconds after the start of the attack, we detected that the aliveness has gone. It's basically at the end of the attack. It wanted to ask the server to go down nicely. The server was busy dying. It didn't listen. So it took like totally 5 minutes to get to the point when it finally said, okay, container, go out, start new one. So yeah, that was the story. And I actually died because of the worker connections got full on the second 23 of the attack when it was just ramping up. So, whenever you are seeing anything happening, do try to get all of the data and which is available from that side, and then go back to all of the steps and see what kind of information you can get from there. For me, I currently have these things in the memos, so next time this happens to me, I can easily copy the strings of the messages from here and just see the same things in the logs very easily. Thank you. We have like 1 minute for questions, considering that there is also a prize for that, then it's possible that you're going to get the prize if you ask now.
Oh. Question? Yes. There's a question there. Maybe you can run with the mic. Wait for a mic. Thanks.
DDoS are usually a result of asynchronous effort. You need to provide more effort than an attacker does. Looking at that and looking at what you've learned in the last couple of years, how would you design a new environment to be as resilient as possible?
Oh, it's. I've been always thinking that I need to build smart protections on my side. So one thing I want to do, which Cloudflare currently doesn't let me do, is to be able to detect if there will be the number of requests with exactly the same path is rising faster than expected. So you can do the rate limiting. By default it is by IP, but with Nginx you can actually specify what you are using for the string, and being able to modify that and decide when exactly you are going to just throw error 500s is something I've been trying to do for a long time, and also using more security to do that if that's available, or then just Nginx's own rate limiting. So I can just throw my hands up and say, oh, error 500, Cloudflare, please save me. And hopefully in 30 seconds the knight Cloudflare and the white horse and whatever arrives. Thanks.
We need some competition for the best question. Maybe one more. anything.
Well, then,
Nope.
yeah, then the only question is also the winning question, and you can later pick a correctly sized hoodie or the voucher for $20 in Starch Press bookshop from the back of the stage.
That's
Thank you.
right. Thank you to Peeters.